In this session, we're going to kind of sum up the whole strategy for factoring polynomials. See if we can put it all together. These are extremely useful when we start working with rational algebraic expressions, so you can imagine those are coming up. Our little review session. Okay, so what's the first thing we generally do is look for a common monomial, right? Do we have a common monomial that we can factor out? Monomial. Oh my goodness, my spelling. My handwriting is worse than my spelling. Okay, what do we have in common here? Well, they both have x's. In fact, I could take out x squared, couldn't I? X squared. What else could I do here? A 3. Having taken that out of this, ooh, what is left? Now here's where you want to make sure you remember the multiplication, identity. Now if that's not obvious to you why I'm saying that, let's think about this for a minute. When this is divided, oh, it's not going to come up yet, is it? Because we're going to have 3 divided by 3, which is 1, and this will give us the plain old x. And this one, when we divide it by 3x squared, is going to come up with 2. What about this? Anytime we see a difference of squares, we think of conjugates, which take the square root of the first term, square root of the second, sum, and difference. Don't you love it when you know the pattern? And we know the pattern for this one as well. This one is going to be a binomial and a trinomial. I'll leave a little more space for that. And we know the binomial always has the same sign. And the other thing we know is we only have one negative. This has to be u squared. This has to be v squared to make any sense at all. We can't have a negative because we already used our negative. So what is this? This is just uv. And this one, I hope you recognize this pattern. This is a perfect square. This is a perfect square. X times 4, right? So the square root of this times the square root of that, and then we double it. If we can do that, then we know we have a perfect square trinomial. Perfect square trinomials have a beautiful little pattern. It's a binomial squared. And what binomial is it? You take the square root of this, the square root of this, and you take the sign of the middle term. Done. First, always look for a common factor. The number of terms that you have can be a clue to what you need to do. If you have 2 terms, this is very likely difference of squares, or sum or difference of cubes. If you have three terms, check to see if you have a perfect squared trinomial. If not, test the factors of the terms. What if you have more than three terms? Is this perhaps a difference of squares with hidden by a perfect square trinomial? And definitely try grouping. Factor completely. Once you have achieved some factors, look and see, could I take this any further? Let's try doing this. So, using our strategy, do we have any common monomial that we could pull out of here? Yes, indeed we do. 5u. I'm afraid that's about it, isn't it? And when we take that out, what are we left with? Well, this becomes 1, 1, and x squared. This becomes negative 4y squared. Remember what we said. Make sure you can't factor further. Actually, with this one, we can factor further, can't we? Because I'm going to write this down so I don't lose it. This certainly looks like it might be a difference of squares. Yes, it is. It's perfect square, perfect square. So we take the square root of the first. We take the square root of the second. The sum and the difference. There it is. How about this one? It looks pretty darn familiar, doesn't it? This will factor into, if we, sum. Oh, a sum. I have to be really careful about this one, don't I? This is not a difference of cubes. This is a sum of cubes. Now I'm thinking that my a is equal to x squared and my b is equal to y squared. So if I look at it that way, I can factor this using the pattern we know from sum of squares, which would be, sum of cubes, sorry. So I'd have x squared here, and because it's a sum, I match that. And over here, x to the fourth, I know I've got that. And y to the fourth, I know I've got that. And I know I'll have, this is positive, and this is negative. And it's going to be x squared, y squared. X squared, y squared. Then the question would be, could I take it any further? I think maybe I could. Not with this one, but maybe I could with this. You tell me if I could have taken it any further. This one, I'm going to look for a common monomial I could take out of this. Let's see. 12 and 27. 3, right? 3. So I can factor out a 3. I can factor out x squared. And I can factor out a y. And what will be left? I'll have a 4, a 1, and a y squared. So 4y squared. And here I'll have left a negative 9, a 1, and a 1. So, does that look right to you? We get 3x square y times, and I see a difference of squares there, don't you? 2y plus 3 and a minus 3. So we're finding we can keep going quite often. And this one, notice how we begin to see other opportunities once we factor out that common monomial. So important. So I've got one here. I can see it already. I know I can factor out a 2. I can't go with a 4. I can't go with a 3. 2 is the best I can do. But I can factor out an a. I can't do anything about u because this one doesn't have a u. So let me try that. 2. Let's see if anything better emerges when I do that. I get 4. Oh, I should have said 2a, right? And then I'll have 4u squared plus 6u plus 9. Hope I didn't make any errors there. And I'm going to think about this for a minute. Could I take it any further? I'm thinking, okay, I could, this is a perfect square and this is a perfect square, so I'm so tempted. Looks like it should do something for me. Oh! You saw it, didn't you? A math error right here. I'll try to fix that. Oh, I'm making it worse. I'll fix that. Yeah, when you divide 24 by 2, you don't get 6. All right. Okay, let's see. This would be 4u squared plus 12u. Now, I might have something. I'm not sure. If I multiply 4 by 9, I get 36. And I look for factors of 36 that when I add them up would be 12. So it certainly isn't 12 and 3. And it isn't 9 and 4. I guess not. I think this is prime. If it's not, you'll let me know, right? All of you looking at it, you'll tell me. Make a note. Make sure you talk to me. If I've missed something here, I'll go back and fix it. How about this one? 2 can be factored out, leaving me with a squared minus 9a plus 18. 1 times 18 is a positive 18. Do we have 2 factors of 18 that when you add them up will give you a negative 9? Indeed we do. Negative 6 times negative 3. So I can go further with this. A minus 3, a minus 6. This one has got to be factoring by grouping. Don't you agree? Well, before I do factoring by grouping, I could make my life a little easier. I'm going to come up here. Make my life a little easier by factoring out this 5. 5's there for everything, isn't it? That leaves me with AC minus AD minus BC. Excuse me. All right. Now I'm going to factor by grouping. Maybe I should change color. Take this and this. I don't want to forget my 5. I'll put big brackets around it so I can just focus in on this. I do have a common factor, a. And when I factor that out, I'm left with c minus d. And for this next one, I have a common factor, it's b. I'm going to factor out a negative b. And when I do that, this will give me a positive c and a negative d. Correct? I hope so. Because I didn't need to put that way over there. Sometimes I don't know how much space I'm going to take. And when I work with this one, now I have 2 common binomials, one in this first term, next one in the second. So I get c minus d times a minus b. Really helps to factor out the common monomial, doesn't it? Oh, look at this. What is going on here? I love this one because, do you recognize that? A perfect square trinomial. Good. So I know I've got x plus 1 squared. That's the way all perfect square trinomials factor into a binomial squared. Then, if I factor out the negative 1, what will happen here? I'll have y squared plus 2y plus 1. True? This is good news also because another perfect square trinomial which factors into this. I like that because I can use this squared minus this squared, a difference of squares, and set up conjugates. They are going to be a little larger than usual though, aren't they? Because my first term is actually a binomial. And my second term is also a binomial. Notice I'm leaving space here, and you know what that's for. Sum, difference, factored. Woohoo! Wouldn't you be proud of yourself doing that one? All right, what's going on here? Ooh, a mess. Can I factor this by grouping? Well, let's try it. Factor out the a, that's the only thing that's common there. And we'll have x cubed minus y cubed. I know how to factor a difference of cubes. And then I'll factor out a negative b, and that will leave me with x cubed minus y cubed. Anybody wondering why that's a minus? When I factor a negative out, the only thing that makes sense is that this becomes minus. And if you start to second guess yourself on this, try multiplying it back to see whether you go back to where you had been. Negative b times positive x cubed would give you negative bx cubed. Negative b times a negative y cubed would give you a positive b y cubed. So that's a way of knowing that you actually have it right. I have a common binomial, which is a difference of cubes. that I'm going to factor out of the first term and the second term, leaving now. Here's where we should follow that last rule and see, can we take this any further? Well, of course we can. And we know how to do it. I'm going to put the A minus B first. And then I'm going to do the factoring of the difference of cubes using our factoring pattern, which is beginning to embed itself in our memory, right? There. Can't go any further than that. I know that one. Factoring, a general strategy. Oh yes, just, didn't we do this? We certainly did. And this, and this. We've already done it. Isn't that cool? And this. There's nothing new here. Nothing new. We just practiced a general strategy, and it worked pretty well.